afternoon, ladies and gentlemen. I'm Andrey Andoko from Universitas Multimedia Nusantara, Indonesia. I would like to share about the holistic approach for creating environmentally friendly campus. Our campus has three parts. The two towers are New Media Tower and Pika Oyong Yakob Utama Tower. Our campus occupies 8-hectare land area and has about 95,000 meters square floor area, with about active student body about 9,000. As we know that the building energy consumption for HVAC is about 47% to 65% of the total energy. And for the lighting, it's about 15% to 25% of the total energy. So to save the energy, our strategy is how to reduce the HVAC and lighting energy consumption. During the design phase, the building energy consumption was simulated using the Energy Plus software. Simulation was conducted by with the data input of the solar path and an historical weather, and also the amount of people in a classroom and amount of heat from its light. So this is the result of the simulation. To realize the energy saving for the building, then the building applied two concepts: passive design, active design. For the active design, there are building orientation, double skin facade, natural ventilation, wall material, natural lighting, and also sustainable landscape. So we see it one by one. Both our orientation are slightly east to west to minimize solar heat gain. The west and eastern side of the building are used for the service area, for elevator and also for the toilet, and north and the south side for the of the building is used for the classroom, laboratory, and also offices. For the double skin facade made from the aluminum panel with a hole, with a porous, then the sunlight hit the skin with about 31 degrees Celsius, and then inside the skin it has been reduced to 28 degrees Celsius. So on the inner side of the double skin, then inside the classroom, it's already down to 26 degrees Celsius. So actually, without the air conditioning, it's already comfortable enough. But then we provide the air conditioning, but with a higher temperature, so it can save the energy. With the double skin facade, then in fact that it has reduced the heat coming through the windows by more than 70%. So it can lower the temperature inside the room. There is a gap between the skin and the wall of the rooms, about 1 meter. So it's used for the air circulation. So the hot air will be circulated around the building. So that's why the temperature inside the class is already reduced. And also the space can be used for the access, for the maintenance, and also for cleaning the windows. And the pores, the position of the pores from the aluminum panel are about the same level as a glass window, so it can maximize the sunlight going into the classroom for the natural lighting. The building also applied the natural ventilation concept. So the building has a lot of open space without air conditioning, and also there are several chimneys. The chimney function as to flow the air from the basement going up. So at the basement there is no electrical exhaust fan. So all using the natural ventilation. And also on the ground floor, it's used for the canteen. It can accommodate up to 1,200 seats. And this area are without air conditioning. So using the natural air, although it's not cool, but it's really comfortable enough for the students or for the staff having lunch in the canteen. So the building applied the cross ventilation concept. So the airflow from all of the side of the building. Inside the building, in the corridor, also there is no air conditioning for the corridor. So we use the natural ventilation concept. So because the corridor occupies 25% of the total floor, it means that we can save or we can reduce the 25% of the energy supposed to be used for the air conditioning. So the building has a lot of open space. We maximize the usage of the natural air. Although it's not cool, but it's comfortable enough for any activity for the students. And also we utilize the natural lighting from the sunlight. It can save the energy by limiting artificial lighting, and also to improve health and well-being because we are using the natural light and enhance the quality of the light environment and to improve the visual comfort. All the walls and also floor and the ceiling are painted with a bright color, so to reflect the light to maximize the natural light. Most of the, more than 80% of the building space uses the natural daylighting. And the light is comfortable enough, so we do not need to turn on the light, but then we still can use the projector. It's bright enough, so it's good for the lecturer. Surrounding the campus, it's a green area, so a lot of plant surrounding the campus, and also inside the tower. On the right picture is top floor of the new media tower. Although inside the building, but then we plant with the trees, so it's like the outdoor space, but although actually it's inside the building. And also in the chimney, we also plant high trees to to make it the airflow from the basement to the upper space. Then we can claim that at UMN Campus, every space is a learning space, whether the students are inside the library with the air conditioning, or maybe in the canteen without air conditioning, and also in the ground floor, a lot of open space that the students can have any activity, whether they are studying or maybe they are doing some practice, and also outside the building. And all of the space are comfortable enough for any activity. For the active design, then we consider about the air conditioning, lighting, and also the water management. For the air conditioning, then the air conditioning, the environmentally friendly chiller with the refrigerant R134A, and also we applied the VSD, variable speed drives, to reduce the energy consumption of the pumps and the motors and increase the life of the machine. And also the enhancement of our chiller plant load efficiency by lowering condensed water temperature of the specific chiller, and then utilization of the variable speed drives for the compressor motor. And also we analyze the operating condition to determine the number and the size of the chiller. For the lighting, for the newer building, we use LED with the electron pillars, so we can reduce the energy consumption. And also LED are durable because it can absorb shock without malfunction. And as the latest initiative, as part of the sustainability program, UMN also utilizes solar energy for street lighting at the moment, but we plan to expand the usage of the solar energy. Okay, at the UMN campus, there is no water wasted. All the water are recycled, either from the rain going to infiltration well, and also the waste. The wastewater are recycled at the STPI, Sewage treatment plant. The STPI at the UMN campus using the biological process using the aerobic bacteria. And the recycled water is used for flushing toilet, a watering plant, and also for the water cooling tower makeup. So there is no water wasted or flown out of the campus. So this is the usage of the recycled water. This is also the latest initiative as a green initiative. Then we have a cooperation with one of the vendors to supply the bicycle. So the students can ride the bicycle going around the campus. Yeah, of course, with a small fee. As a summary, if based on the 2019 electricity consumption index, actually the average campus building consume about 200 kilowatt hour per meter square per year. But then our building, the NMT, the New Media Tower building, only consume 66 kilowatt hour per meter square per year, while PK Oyong Yakob Utama Tower consume only 61 kilowatt hour per meter square per year. It means that we can save 65% of the energy consumption. That's why those two buildings were awarded as the first winner. The New Media Tower has won the first winner, and the Pekayong Yakob Utama Tower won the first runner-up at the ASEAN Energy Award, because those two buildings can save up to 67% of the energy consumption. Okay, that's all that I can share to you. Thank you very much for your attention. If you want to contact me, please contact through my email, andre@umn.ac.ad. Thank you very much.